Hello all, I am Naren from School of Chemical and Biotechnology SASTRA. This video is part of the Fluid Mechanics for Process Engineers course that I teach at SASTRA. This is a module 7 and the learning capsule 7.1 on the capillary rise. We will see some examples of how fluid flow will happen, and they are happening without a pump. So that's something strange. Whenever a fluid flow happens, we expect that there should be a pump, and the pump is a device that helps in pumping the fluid from one position to another position, from one location to another location. But now we are going to see of a situation where there is no requirement of a pump. Let's see some examples and then we'll go to the basics. Now this is a very common example that everybody might have come through. Is like if you dip a wick, right? If you dip a wick in a fluid, now this could be oil or this could be water as such. Now what you will see is slowly this fluid will race through this wick, and you can at times see dripping is also happening. So is there a fluid transport? Is there a fluid flow happening in this case? Certainly yes, right? Because initially we never had when you dripped the wick into this fluid, there was no fluid in this wick. It was a very dry wick, and then this fluid started flowing, and one could actually see that there might be some dripping also happening. Now if I just enlarged it and shown what is seen here, let's say if this one end of the wick is wet with the fluid, is dipped in fluid, I just showed it as an horizontal as just 3 threads for the sake of simplicity, but you can imagine that it can have any number of threads. We can see that this fluid slowly tries to move, right, and occupy all these spaces, and you can see that the fluid will reach this end. This is quite an observation which we have already seen in our day-to-day context. So certainly there is fluid flow, but then is there any pump? Right? No, not at all. Right? We don't have any pump in this fluid, but certainly there is a directional motion. Is it clear? So the fluid is able to move from one end to another end. So that means there is a fluid motion possible, and this fluid motion is possible in a direction, right? And you don't see a pump. Let's take another example. Now let's say suppose if you have sand, so this is, let us assume this is sand mixed with gravel and so forth. If you just put water on the top of the surface, so on the earth's surface, now it is very possible that the water actually seeps down. Now if you are asking the reason for this, right, the reason for this, you might quote this to be gravity as a reason, right? It is quite possible that gravity could be a reason, because you understand that yes, we have kept the fluid in position and the fluid flow is happening into the earth, so that means in the direction of gravity. So maybe we can think that this is a gravity induced flow. But just take another example that I have marked here. But suppose if there is a water body inside the earth's surface, which is indeed, that is how we drill and then take water. Now in this case the water seeps actually laterally, and you can see that these wall water channels are connected. Now how can you explain this motion? Now there is certainly no gravity, in the sense no gravity. What I mean here is not the gravitational field is zero, but you see here a lateral movement, which is very different from this a vertical movement. So there is a lateral motion possible, and again there is no pump here, but the fluid flow is happening. Maybe in this case you might tell, or we might tell that the flow quantity okay, is negligible, right? But certainly not in this case. The amount of fluid that flows like this is not certainly like this. It's certainly not negligible. Let's take from these abstract examples a lot of other applications which is based on such fluid flow without a use of pump. One is our ink pen, the traditional ink pen. Like, can you think of how ink from the barrel, okay, flows into the nib, right? Do you see here there is a fluid flow? Yes, a fluid flow is there, right? Fluid flow is there, and it is certainly controlled fluid flow based on the different size of nibs, right? The spacing in the nibs, you can either have more ink to flow or a very minimal quantity of ink to flow. So that is certainly a fluid flow happening. You can same think of this in terms of a tissue paper, okay, how it takes water. Okay, when you just use it for wiping the water on a table, again there is a fluid flow and you don't have a pump, right? And this the tissue paper takes the water as you just use tissue paper to wipe the water on a table, then it takes the water. What you mean by it takes the water is the water flows into the small channels within the tissue paper. One can also have a very recent example which I wish that you go through after seeing this video, is on the microfluidics, or especially the paper based microfluidics, okay, and this is predominantly used in terms of diagnostic kits, right? You might see that we just put a drop of blood or any body fluid on an element which is like a porous paper, and there are channels wherein the fluid flows, and by using this system, right, we can detect any abnormality or the components that is present in the body fluid. This microfluidics is also gaining importance in terms of the reactions that it can be performed. Now, very connected to this is the larger one, a slightly technical word. These are all at least very common man's understanding, is something to do with the chromatography. Okay, so the principle in the paper chromatography is again based on motion of a fluid stream, wherein a directed motion of a fluid stream, and it is not aided by the pump. One can build like this examples and observations in all across nature and in also in our day-to-day applications. Like one more at least which I can add just to make sure that it is comprehensive in terms of biological observation also, that it is in plants how water move through the xylem, especially from the root towards the shoot, especially if it is a very tall plant, right? We certainly have like this, right? So that means in all these cases, we see a motion of a fluid, and certainly, so that means there is a possibility of a fluid motion, and it is certainly an appreciable amount, so it is not like something that we can ignore, and in all these cases there is no pump. So that means there is another at least one phenomena that we should think of which can cause fluid motion, and that's what we are going to see in the follow-up learning capsule as the capillary force, right? And how capillary rise happens. So that means when you dip fluid into a very small channel, what makes the fluid to move, and can we estimate how much a fluid can move through a given capillary? Thanks for watching this video.